Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lessons. We're on number 64, and we're talking more about classes. This is the second video on classes, and uh, tied it into the Pico W with the LEDs and everything. And it was a good class. And then at the end, he asked us to do the homework on uh, creating a servo class. So I actually had done that when we went over servos before because I was working on a quad walker robot and I needed to control a lot of servos at the same time. So um, I had worked on a servo class for doing that, and I've already put in a comment in it on this video that I I had done that and pointed to the video. So if anybody's interested, uh, you can look at that video. One thing that I was concerned about with Paul's thing here is that he's blinking two LEDs, but he's blinking them consecutively. Um, and I thought, well, we go to all trouble making a class. We ought to be able to make them blink concurrently or at the same time at whatever speeds we want to do it with. And with the PyPico, there's several ways of doing that. In MicroPython, there's several ways of doing it. We have two cores on PyPico, so you could actually, if you're just doing two, you could do one on each core and blink them at the same time. That's using the hardware to the best advantage. But there's also several ways to do it that I can think of. Um, Using either the built-in MicroPython or other modules out there. One that came to mind is they have a timer class in um, MicroPython, and it's under machine and timer. And I think I didn't look at it, but I think that could be used to tell you to blink when you needed to and do or just it would run a function when you called it so you could flip the lead to on or off when the function's called. And another one that I've only delved into a little bit and I'm not comfortable using it is the async IO module for MicroPython. And it's more or less like a scheduler that you can schedule, slices of the computer time. And then when you're done with what you want, what you want to do, like if you flip a lead, you can tell it await, they call it. And when you await, and then it goes off and lets the uh, program do other things. And each process would have an await on it, so it would do a little bit of work and then yield to the next process. Um, that's probably the best way of doing it, but I figure we haven't gotten into that yet. So I figured I'd stick with what Paul's already taught us, and so kind of come up with a class that I call Blink. So let's get up to Thorny. So here's the class that I created. Um, like I said, Paul imported machine down in as a init, but I needed time and machine, so I can just go ahead. I went ahead and did it at the top. Um, so that you only have to call it once. I don't think it hurts to call it for each object, but still. So, so instead of just doing a LED object like Paul did, I'm actually calling the object, but it's going to be with the purpose of blinking it. Um, you're not creating a LED object on its own. You're setting it up to be a blinking object. And so in our init, we're bringing in our self, of course, and the pin, which we need. But then I have an on time and an off time. So if you want to blink, turn it on for 3,000 milliseconds and turn it off for 1,000 milliseconds or 1 second, then you can do it. If you want it on and off at the same time, you just have to make those two numbers the same. And also, Paul had it so that it would blink a certain number of blinks. And I thought, well, that might be a good idea to do that. It'd been a little bit easier if I just made them blink forever. But I said, well, it shouldn't be too much harder to do it that way. So instead of bringing a separate uh, attribute in, I just making this equal to none at the beginning. And then down in here, I'll show you what we're going to do down there. But um, if you don't add a number of blinks to your initializing call, then it'll be a forever one. Okay, so let's go ahead down here. So of course the pin, like Paul said, you got the you bring in the pin and then the pin out, and then you're making an object out of it that you'll need in that further in your program. And then also, since we're doing this so that we can do things concurrently, you need to keep track of your milliseconds on your machine. Under on Arduino, they call it millis, but in here it's called time.tick.milliseconds. So we're keeping track of our milliseconds there. So as soon as I initialize it, I'm creating a previous time or the start time or whatever you want to call it of the first uh, on time. And then the blink time, because I want to take care of this more easy, I put it into a list. I took the on time as going to be list position 0 and off time is list position 1. That way I can refer to it by index instead of doing it, you know, referring to on time and off time. I think it made my code a little cleaner. So we did that. And then I also needed to have the blink state, which is 1 for on and 0 for off. I decided I needed a blink state variable as well. And here's where I'm deciding whether it's going to be a forever uh, blinking or if it's going to be a certain number of blinks and then stop. So like I said, we're defaulting on here to none, which means it's going to be a forever blink. So I say if num blinks is none, which it is if you don't do anything, then I'm just giving a number to num blinks, self.num blinks, and then setting another flag variable forever to true and self.forever to true. And then if none blinks has a number in it, if you put a number in there, then you're going to, your self.num blinks is going to equal to num blinks, and which is up here, and that works out good there. And then forever is false, and I'll use that down here. So this initializes it and actually doesn't turn on or off the lights at all. It just initializes it and sets everything up for what you're going to do later on. And so we'll get down to our next function is our next method is called check. So the thing is like I said, you got to check this very quickly and you got to do it every time through a while true loop. So your while true loop cannot have any kind of delays in it or large delays in it. So you have to do, make sure that the rest of your code doesn't use delays as well. So we have, like I said, the check. And the first thing it's going to check, if you happen to have, if you're going to have a number of blinks and your number of blinks has got down to 0 or below on a one that has a number of blinks, there's no way not to check it, or it doesn't seem like it's practical to try to delete or uh, cancel instance that you have. So it's just going to keep checking it, but it's just going to return out of without doing anything. If your blinks are at 0, it's not going to do any of the rest of the work. So the next thing we check on is whether we call this time.ticks.differential. That does the subtraction. This is a better way of doing subtraction because it takes into account any kind of rollover or anything that you have if your code's running a long time. And so what we're doing is we're actually getting the new time, which is going to be a higher number, and subtracting the previous time. And then we're checking the return of this to check and see if that number is greater than the self dot blink time. Uh, and then our blink state that we created up here where we started off with it on. So our blink state index of blink state. So we're actually checking on the uh, off time at this point because we're on 1 instead of 0. But just the way it worked out to do that. And then if it's time to change the state, then it'll do this. If it doesn't do that, it just falls out and returns because there's nothing else for it to do. But once it's whichever state it's in, once it gets up to that number, then it's going to go ahead and do this. And first thing it's going to do is make sure the previous time gets updated because otherwise it's never going to go off or whatever and never going to change. And then you're going to set the object value to whatever the blink state is. So the blink state is either going to be 0 or 1. Um, and and then so whatever that it was when it went into this, blink state's already there. But then after we set that, then the blink state is going to change. So blink state, this is using that modulo math that we can use to change the state. We could have used uh, a Boolean value for blink state and just said, true. And then down here, we could have said blink state is not blink state. And then it would have changed over. But I like using this Boolean thing mainly because if you had more than 2 states that you wanted something in, you would just change this number. If you had 3 or 4 states, you would just use this same format and then just change whatever you're doing your division by, and you could have as many states as you wanted, and then it would automatically roll back to 0 once it got up to the max number of states. So this is either going to return a 0 or a 1, so it's going to keep doing that. And then we're going to check if uh, if the blink state is in a certain state. So I'm saying 1 here. I don't know whether it matters, but I just said you don't want to do it every time. You want to do it on one or the other. So I chose 1. So blink state is equivalent to 1, and the forever is false. That means we're have a finite number of blinks that we want to do. Then we're going to do self dot blinks in minus equals 1. So we're decrementing the blinks by 1. So and that's basically what it does. And then, like I said, each time through here, it's going to check to see if the next if it's time to change the state again. And like I said, by making this a class, we can have as many LEDs as probably pins on the thing. So we'll see how we do it. So I've used 4 different. I wired up the onboard lead which is, you refer to it as capital LED, and when you want to do the pin out, pin dot out thing on there. So you refer to it as LED. And then, like I said, this is the on time and off time for that LED. And then I just called these L11, L12, and L13 legal because that's equivalent to the pins there. Just because I like short variable names. So this very first one, or this number 11 here, L11, I have pin 11. I have an on time and then an off time, but I have that third variable or attribute in here, and it's telling it just to do 20 blinks 20 times on, and that's the only one I did that to. So when we run it, we'll see that it starts blinking, and after a period of time, 20 blinks, it's going to stop doing it. And then 12, I have a real short blink, so it's going to blink kind of fast. And then 13 is a longer blink, and it's going to do it. So like I said, I got all different numbers on, or values on here, so it can do that. So I guess the thing to do, I wired it up. I don't know how much you can see this, but it's just the red, yellow, and blue LEDs. And then, of course, the onboard LED over here. You'll be able to see them when they blink, but they're just wired up basically. I got a lot of other wiring on here that I just didn't remove, but got the 3 LEDs on there. So we can go ahead and let it run, I guess. And we can see that the 3 LEDs are blinking all at different rates, and the onboard LED is blinking. And you can see the red one there, it's blinking, but eventually you're going to see it stop. There you go. So it's stopped. It did its 20 blinks and it stopped. Of course, like I said, we can't restart that without restarting the program, or because it timed out on the while true. So I don't know how useful that would be, but like I said, the blue LED's got a 3-second on and a 1 second off, and the yellow one, it's got only 100 or 200 milliseconds on it. And you can see the onboard LED over here is still blinking on and off. So everything's working, and like I said, the class itself is 25 lines or whatever, but then you have to initialize each one of them that you're going to do, and then while you're in your while true loop, you have to run this check at least, I would say, at least every millisecond. I mean, you're probably not going to have your LEDs, your numbers on your LEDs any lower or higher than 100 milliseconds, but you have to have time for all of them to run. So when you do this, you're going to have to, like I said, you can't have any delays or anything in your uh, uh, in your while true loop. Like if you were maybe drawing something in OLED or something like that, like the spirals or something like we did at one point, that would not work and have the LED going at the same time. Possibly async IO could take care of all of that together. I think async IO might have a OLED tied into the OLED method as well, but I'm not sure. But anyhow, that's my not homework for the week. I was concerned that Paul had those two LEDs blinking one after the other, and I wanted to show that you can make them blink all at the same time if you want to, at different rates and everything. Anyhow, thanks for watching. Thanks, Paul, for the videos. Keep learning from you. Talk to you later. Bye.